Okay, the next board I'm going to look at is, well, it's an Atari board. I'm not sure what this is. What's confusing me is the time stamp or the date on it, 1973. I was thinking this was a Pong, two-player Pong, but it's not. It can't be, because that was 1972. So 1973, this might be a four-player version. It's got a bunch of 555 looking chips here, but no potentiometer adjustments. So a little confused about this one. This might be a four-player hockey type thing from Atari, or it might be something completely different. Pretty sure it's going to be Pong based, though. It's not going to be Breakout. Breakout didn't come out until like 1975. So I don't know what this is. And so I won't have the pinout. I'll have to figure out the pinout. And so it's going to take me a little while to build a connector, but I'm going to get started on it. First things first, though, this is kind of dirty, so I'm going to give it a good clean. I'll be back. All right, so I've got it cleaned off, and I've dried it off pretty good, so it's ready to be messed with. This does appear to be an Atari Doubles, Pong Doubles board. I found the schematics online, but the four paddles, like here's an example of one of the paddles. It shows that there's supposed to be trimmer pots on the board, and there are none. And so there's one paddle. Let's see where the other three are. There's one up here in the corner. There's one down here. And there's another one, I saw it earlier. Right there. There's the fourth one. So all of them have the potentiometer being shown. Where is it over on this one? There it is. So that one's the potentiometer, and there's a potentiometer. So there's supposed to be four potentiometers, and basically they trim in to center the pads for each player in conjunction with these 555 timers. And it should be right in this area, the pots, but I'm not seeing them, so I'm not sure what that's all about. Also, when I was cleaning it, I noticed this. You can pick 2/4 or 4 players. So if you want to allow a 2-player game for 1 coin, I guess you put it in that position. I saw some interesting stuff that may or may not be factory. I've got a jumper wire here. I believe that is factory, but I don't know for a fact. I saw some what I thought was damage repair. Where was it? On the backside, maybe? Yeah, on the backside. So somebody put a jumper or something there, and it's a diode, okay? So there's a diode there. I can see it with my glasses. Somebody added a diode and covered it. That may be factory. I don't know. So I'm gonna have to build a connector first. I've got my edge connector ready to go. I'm gonna have to find some wires and build up a harness that plugs into my test fixture. So that's what I'll be doing next. So I've got a test harness half-ass wired up here, and I've checked the voltages. They're there. Getting nothing on the screen. Nothing. The pinout for this board does seem to match the schematic. Only the pinout of the board. In other words, the pinout going to the connector. I think that's correct with respect to the schematic. However, when you start looking at the chip locations, nothing's lining up. For example, I was expecting to find these 93s up at F9 and F10, but when you go over to F9 and F10, so here's 9 and 10 here, A, B, C, D, E, F, so these two guys here, they are 74s. So both of them are 74s. Flip-flops. They're not counters. So, yeah, and nothing's lining up at all. Everything is completely different than this. So this schematic does not match this board. Therefore, this board is not an Atari Doubles Tennis. It's not. I think there was something called Quadrapong that Atari made. I'm going to look at that and see if it's that. Not sure, but I'm going to get online and see if I can figure out what board this is and then get the proper schematic, because there's nothing I can do. I mean, I can probe around, and a lot of the things are, you know, the schematic design, the design of the board is going to be very similar to this with subtle differences to make the differences in the game. But the clock circuit and the ball position circuitry, The sync generation, all that stuff is going to probably be exactly the same. It's just going to be in different locations. The chips are not going to be where I can find them easily. So that's it. That's all I can do tonight with this. I did get the harness finished, and I am getting power to it, and it looks good. And but no image. So I will continue on this some other time. It's the next day now, and I have had a chance to search online to find out what this board is, and I figured it out, I'm pretty sure. And I found schematics for it as well. So we are in business again. This is a Quadrapong by Atari. And the schematics for the cabinet have the wiring for the power and the LED and the coin switch to be the same as the Doubles Pong. The only differences are the controls. The controls on the Quadrapong are on a higher numbered pins, whereas they're on the lower numbered pins for the Quadrapong, or the Pong Doubles, sorry. Pong Doubles, Quadrapong. So I've spot checked a few of the chips, and they do match with the schematics that I have for Quadrapong. And this is cool. This is actually, I think, a very valuable board compared to the Doubles Pong. So I'm excited about that. I've never actually seen one of these in person or ever. You know, I've seen them, I've seen pictures of them, I've seen videos of them, but I've never seen the game in physical reality. And I've never seen a board in reality. This is it. Now, I've had this for a while. I didn't know what it was. So one thing that was tripping me up was this crystal. There's a number printed on the top of it. The schematic says it needs to be a 14.314 something megahertz, and the number printed on here is 7351. What I think that number is the serial number. So they made at least 7351 of these boards. I believe that's what it is. So that's that mystery solved. This is a 14.1 megahertz crystal. It is, or 14.3, whatever. It is printed on the side of this, and it matches the schematic. So now what I'm going to do is I'm going to apply power to it, and I'm going to try to figure out why we have no activity at all. And we're going to be focusing on the oscillator, which is here, which I've already kind of know that that's working. But why aren't these counters working? So I need to make sure the signal from the oscillator is getting over to the counters, the clock of it, and see why these aren't counting. One thing of interest is it looks like somebody did some work on the counters that I'm interested in. The first stage of the clocks right here. I'm going to see if I can get over this to see it. You can see there's some solder work there. So I've got to double check and make sure that's correct. Also, this jumper wire that goes from here to here, I believe that's factory. It should go from pin 1 of this chip to pin 3 of this, and I need to confirm that that's correct and not shorting. So let me do all that work and I'll be back. All right, so I'm focusing on the first stage of this counter chain. And on pin 14, that's the clock signal coming from the oscillator. This chip is allowing the signal to come through, all right? So I am getting a clock signal here, and it does look valid. It looks like it's crossing low and high boundaries for triggering. So this thing should be counting, but it's not. Pin 12 is the first output for the low bit, and it's being fed back into pin 1. Not sure what that's all about. I haven't looked up what this pinout is, but this should be toggling up and down, you know, at half the rate of that. And this guy here is not. It's floating. So I'm going to start by replacing this 7493 counter. It's a 4-bit counter, and we'll see what happens there. Also, I'm going to reroute that wire that was added to the back side of the board instead of the top side. It just makes it a little cleaner. All right, so that 7493 that had no activity has been removed and socketed, and when I removed it, I've discovered that 2 of the pins were broken. I've soldered the pins back on, so I'm going to test it in the retro chip tester, and let's see if it's any good. If it's bad, then I got to find one. I don't have one. I've been looking around. I don't have a new one of these. I'll have to find a board and yank it off of it. So this thing is supposed to be able to do logic verification. I had asked Stefan, the guy that created this board, if he could make it where you put in a chip and it just automatically identifies, you know, the functionality. But he hasn't done that yet, I don't think. Maybe in a future update, I don't know. But a lot of testers for like your Zeltex for your PCs, they did that, and it was great. You just plug it in, you'd push a button, and it would tell you which part numbers it matched. And if the part number that the chip was that you were testing showed up, then it was good. Really like that. I asked him to do that, but we'll see. All right, so this is a 7493. Whoop. I want to go to 74 plus. There it goes. 7493. So you can see how this isn't as convenient, right? I'm having to go and select the actual device I want to test. Well, I mean, he should leave that functionality, but also have, you know, an auto identify thing. And I would use that and it'd be real quick then. Yeah, so that chip is bad. That's what I was afraid of. And so I've got to find one. I've ordered some because I don't have any new ones. I've ordered them, but it'll be a week or so before they come in. And let's see what that. Oh, there's some interesting things there. It's telling us what failed, maybe, or maybe that's the pattern. Anyway, chip is bad. So yeah, I've ordered some of these. They'll come in a week or so. But if I can find one on an old board, I'll pull it off and I'll test in this checker, the tester. And if it comes up good, then I'll slap it in here. All right, I'll be back. Alrighty, so I found a 7493 off of a board I'm going to be repairing sometime in the future project. Not quite ready to start on that one yet, so borrowing a chip from it. I don't know if it's good or not yet, so let's test it. And put them in the tester, latch it down, and go. No, it's bad. Am I putting these in right? 7493, 7493. This one might be bad too. Darn it. Yep. All right, well, let me see if I can find another one. Okay, so I noticed something in the retro chip tester. There's three different 7493 settings. I tried all three, and none of them say this was good. But I figured, okay, let's go ahead and put it in and try it. And yes, it's doing something now. We've got a screen. So I need to put a connector on the end of the wire for the sync and try to figure out where I can sync off of so we can get a picture. And let me figure that out, and I will be back. So the sync signal that I'm interested in is right here. They're labeling it as composite sync. So I need to attach to that line, which is on the resistor, to the output. Okay, they're building a composite video signal, which mixes all the different graphics together. And I basically need to clip just on the other side of that signal. The signal goes through this capacitor here. That's what this capacitor is right here. So they have a capacitor coupler going to the output, right there. And the resistors, all the resistors that tie together to generate the output signal through that capacitor are in a row. And it's the third resistor that I need to attach to. When I do that, looks like I've got the gameplay. I don't know if there's any problems with gameplay or not. I don't have controls hooked up yet, so that'll be the next thing to do. That'll be a tomorrow thing because it's midnight right now. And it's fixing to start raining, so I'm going to go inside, shower, and go to bed. And I will continue this tomorrow or in the near future. Hey, thanks for watching.